Okay. Bienvenue, bonjour tout le monde. Thank you everyone for coming to the 37th event of Disrupting Disruptions, the Feminist and Accessible Publishing, Communications, and Technologies Practices Speaker and Workshop Series. I'm Dr. Alex Ketchum, and I'm a professor of feminist and social justice studies at McGill and the organizer of this series. The Feminist and Accessible Publishing, Communications, and Technologies Practices Speaker and Workshop Series seeks to bring together scholars, creators, people in industry working at the intersections of digital humanities, computer science, feminist studies, disability studies, communication studies, LGBTQ studies, history, and critical race theory. We are hosting 12 free virtual and professionally captioned events this winter, and you're welcome to join us at all of them. You can find our full schedule as well as video recordings of our past events at disruptingdisruptions.com. So that's the redirect URL, disruptingdisruptions.com. You can also find our list of sponsors, including Shirk, Milieu, and the Indigenous Futures Lab. Next Wednesday, Stephanie Dinkins will be discussing how her art practice confronts questions of bias in AI, data sovereignty, and social equity. On the 24th, Rose Eveleth of Flash Forward Pod will speak about imagining better futures. And for our last event of the semester, Kate Crawford will be speaking about her new book, Atlas of AI. For this event, recording is enabled, so the event can be embedded on our website. Don't worry though, only the speakers will be shown in the video. We also have a Q&A option available below. So throughout the talk, you may type your questions in the question and answer box, and it'll be sometime at the end for Morgan to answer them. We can't guarantee that every question will be answered, but we are grateful to the discussion that you generate. Thank you to our captionist for today, Fenella. Past series speakers Suzanne Kite and Jess McLean have pointed to the physical and material impacts of the digital world. While the events this semester are virtual, everything that we do is tied to the land and the space that we are on. The virtual is tied to the earth. Furthermore, as the series seeks to draw attention to power relations that have been invisibilized, it is important to acknowledge Canada's long colonial history and current political practices. Today's event is in part hosted by the IGSF of McGill University, which is located in Tiohtià:ke, Montreal, on unceded Kanien'kehá:ka territory. Furthermore, the ongoing organizing efforts across this continent, such as the organizing of the Wet'suwet'en people at the Unistoten camp, make clear the ever-present and ongoing colonial violence in Canada. Interwoven with this history of colonization is one of enslavement and racism. For example, as I mentioned before, the series is affiliated with McGill University. The university's namesake, James McGill, enslaved Black and Indigenous peoples. It was in part from the money he acquired through these violent acts that McGill University was founded. These histories are here with us in this space and inform the conversations that we have today. I encourage you to learn more about the lands that you are on. nativeland.ca is a fantastic resource for doing so. Now for today's event. Morgan Klaus Scheuerman is a PhD student of information science at the University of Colorado Boulder. His research focuses on the intersection of technical infrastructure and marginalized identities. In particular, he examines how gender and race characteristics are embedded into algorithmic infrastructures and how those permeations influence the entire system. His recent work explores how gender and race classification and computer vision technologies excludes and endangers at-risk individuals. Thank you, Morgan, for being here, and thank you to everyone in attendance.
Thank you for having me. Just give me a second and I'll pull up my slides so we can get started. Great. Can you see the slides?
Yes.
Cool. So I am going to be looking a little bit downwards to view the notes, but I am, just to put that out there. But hi, I am Morgan Klaus Scheuerman. Thank you for that introduction. So I don't have to introduce myself, but I'm going to be talking about how we teach computer vision technology to see social identities like race and gender. And so I'm going to talk about two empirical studies that I've done that are relevant to each other and about this topic. So first, I'm going to focus on specifically gender and how computer vision classifies people of varying gender identities. So have you ever thought about how you as an individual might be seen by your technology? What would it think about you? What labels do you think it would use to determine who you are? And a lot of technologies are already doing this as we speak. They're making really simple determinations about the humans that they're coming into contact with and bucketing them into terms like woman, female, age 21 to 24. In this presentation, I'm going to talk specifically about a specific classification technology, that is computer vision, and more specifically, how computer vision that uses facial analysis techniques sees identities like gender. So I had this question when I was, prior to doing the study, what does computer vision think about me? And so I kind of anecdotally took a look at different classifications of myself. So for example, Microsoft classified me as happy, 20 years old and male. And then IBM classified me as age 13 to 16, which is very amusing to me, and female, which would be a misclassification. You can also see that it labeled me as a cat fancier, which is correct. But you can also see that this isn't a gender classification. This is an instance of object labeling. But I will talk about how gender shows up in object labeling as well. But it was interesting to me that these two systems classify my gender totally differently. So then how does computer vision see and determine what gender is? So we know a little bit about what gender is to computer vision from previous literature. Classifying gender is actually one of the most pervasive forms of facial classification in computer vision research. And it's proposed in a variety of applications, such as authentication and security use cases, personalized targeted marketing based on your gender, and even personalized human-robot interactions. So the idea here is that your robot will interact with you differently depending on what it perceives your gender to be. We also already know from previous research in this space that women with darker skin are frequently misclassified and misgendered by these systems, that the academic computer vision literature on gender classification uses a gender binary, and also that from my own previous work, that trans people are really concerned about this technology. So they are concerned about power, how this technology can be used, and also just what the implications are for being potentially misgendered by this technology. And so I was really inspired to do an empirical study on that issue of what happens when trans people interact with these systems and how are they classified. And so gender classification sits in opposition with a lot of gendered history and gender theory. So this is a map by PBS that kind of highlights the gender diverse cultures across the globe. And so gender classification kind of sits in opposition and imposes a really specific, generally Western worldview of gender. And it generally uses a binary and gender theory. There are numerous theories discussing gender beyond that and what gender actually means. And so gender theory and trans studies, there are a million perspectives that you can take from those fields, but kind of as some examples, some propose gender as a subjectively self-held identity, so it's something that's internal to you. Others might theorize gender as an external expression that's made to others, a sort of what are you portraying when you are interacting with people around you, so this interpersonal view of gender. And Similarly, it could be considered a social construct that's maintained through performative acts that are expected of us. And so it's this kind of looping of we adopt a gendered behavior, and then we portray that gender, and it just kind of reinforces that gender as real. So given this background knowledge, I was interested in answering 3 research questions with this project. The first is how do commercial facial analysis systems codify gender characteristics, both in the facial classification itself, so that is kind of the male, female returned, and then through the labels. The second was how accurate are commercial facial analysis systems at classifying images of diverse genders? So not solely kind of the things that you would normally see in computer vision data sets, which are just men and women, presumably cisgender men and women, but also, you know, binary trans people and non-binary genders. And how do individuals self-describe their own internal gender identity, and how does this compare with the descriptions that the facial analysis services provide? So kind of comparing how people are talking about and viewing their own identity with what is returned by these systems. So I did 2 phases for this specific study, and the first was kind of a technical analysis of the functionality of 10 different commercial systems. So this was including, you know, Face++, IBM, Microsoft, Clarify, et cetera. Just looking at what the capabilities in terms of gender were for these systems. And the second phase was a performance analysis and a content evaluation on 5 of those commercially available systems. And I'll talk a little more about how I narrowed those down. But I am specifically going to focus on phase 2 for the purposes of this talk. So the evaluation of 5 commercial facial analysis services. So I just wanted to put kind of a high level pipeline of what I'm talking about here to make it a little more clear, hopefully. So there are kind of 2, I call them pipelines, but whether that is, yeah. So there are 2 kind of pipelines of these systems. So on one hand, you have facial classification. On the other hand, you have object labeling. So for both of these, you would input an image, but for the first relies on facial detection. So system will be trained to identify whether there is a face in the image. And then from there, if there is a face, return always the same kind of classification. So every time it detects a face, it would return in, for example, gender and a score. Whereas with object labeling, you would input an image. The system would be trained to recognize kind of certain objects that are common and associate those with certain labels. So in this case, one can assume that because a cat was detected in my image, potentially a cat and a face was detected in my image. So it led to the label cat fancier. And so this is just associated patterns with different labels associated with certain types of images. So to do this study, we actually had to create a data set. So there are not many data sets that have trans people in them. I know of one, but it's rather, you know, problematic in that it was collected to identify trans people across transition for the case of facial recognition. And so that is not really what I was looking for. I wanted a diverse kind of array of faces to test so that I could compare classification rates. And so to do this, I created a data set using Instagram hashtags. So there's a little bit more detail in this publication about, you know, how we came up with those hashtags, but the 7 hashtags that were used in the study were man, woman, trans woman, agender, genderqueer, and non-binary. And we treated people's hashtag use as ground truth data. And so this was the true data, the true label that the image should be associated with. But we did make some assumptions in order to do our study. And so, for example, if it was hashtag man, we assume that the person would want to be classified as male by a system, and that would be a correct classification. And similarly, if it was hashtag trans man, we would assume that they would want hashtag male to be correct. That could not necessarily be the case, but we kind of had to simplify a little bit for the purposes of the study. And so we wound up scraping images that were publicly posted from Instagram, which is definitely, you know, it's a huge ethical conversation, particularly in the machine learning space. And we do talk a little bit about the ethics of the trade-off of, you know, being able to do this study versus not, and how we went about making sure that these images actually were not publicly shared. But in the end, we had 350 images per gender, so 2,450 photos total. And the genders were all self-labeled by the authors with the hashtag. And so we discussed more about the ethical implications of data set construction, and also that we purposely did not use services that in their terms of use said that they would retain images for training. So we did not use Face++, for example. So we selected the 5 services mostly based on, you know, whether they retain that information. So we wound up with Microsoft, IBM, Google, Clarify, and Amazon. For all of the images, we processed them through each of these services, collected the JSON outputs, and then conducted 2 analyses on the outputs. So the first was the true positive rate for each gender classification. And the true positive rate is that the classification returned matches correctly the classification that is expected. So the label, the hashtag label that we would expect to see. And then the content analysis of JSON outputs and Instagram captions, which were analyzed for gendered in the labeling that the systems returned, and also how people talked about and discussed their gender in their Instagram captions. And so from this, we found 2 major things. The first is there was a large difference in classification performance across groups. And the second is that there are gender norms embedded in the labels as well as the classification. So first, I'm going to look at the findings from the first pipeline. That is the facial classification, male, female, whatever binary classification is returned. So this is kind of a high level of the average true positive rates across the 4 binary genders. So those classified most often in our data set were women. So those who use the hashtag woman. So they were correctly classified 98.3% of the time. And those who were misclassified the most often were those who used the hashtag trans men, trans man, which on average across all of the services were classified 70.5% correctly. And then, of course, because these systems are unable and were not designed to return anything beyond the binary, it was impossible to actually empirically assess the classification rates of agender, genderqueer, and non-binary people, because the task of correctly classifying non-binary people is just not possible in these systems. So one could say that, you know, they were classified incorrectly they were classified correctly none of the time, because regardless, you would get a male or female classification back. So I just wanted to highlight a few other kind of interesting findings. This chart is showing all of the classification rates for each service. So the first is that it was interesting that trans women were classified well by some systems and pretty poorly by others. And in this case, Clarify, which is a smaller startup computer vision company, did a better job classifying did a worse job classifying trans women than IBM's system, which actually returned 94.3% correctly. And then Amazon's system actually did the worst when it came to trans men, which is really interesting because it is such a large company with a lot of resources, and was the lowest of all, classification rates for all genders for trans men. So it was 61.7%. And much like I discussed when I was showing the images of myself, gender classification differs across these services. So the same image could be classified as female by Microsoft Azure's API and male by Amazon Recognition's API. And so this shows kind of differing perspectives returned and calcified within these systems. So now I'm going to talk about the second pipeline, which is the object labeling. And services that included image labeling tended to be gendered as well. Masculinity was often portrayed as kind of the neutral position, so it's rarely used as a modifier in the labels, whereas femininity was used to further describe otherwise neutral terms. So explicit femininity was often invoked with labels like starlet or women's portrait photo, for example, whereas a male image might be just adult person or just portrait photo. And gender classification was decoupled from gender labeling. So the two pipelines are separate and do not rely on one another. So the classification doesn't determine the labels, and the labels do not determine the classification. So for example, you might have an image that is classified as male, but then you would have all labels that are woman, girl, lady, and maybe there might be a man thrown in there as well. And so this kind of contradicts the expectations of cultural constructs of gender determining labels. So makeup being feminine doesn't necessarily lead to feminine labeling, but it's actually very difficult for humans to determine how these services are making labeling decisions and what specific objects in the images these labels are being tied to. Similarly, when looking at the Instagram commentary on some people's images and comparing that to the returned classifications, we see social issues and social concerns becoming part of a technical reality. For example, one of the Instagram users wrote that they spent an hour getting ready as a trans woman just to be addressed as sir at the store, and that was very upsetting for them. And then similarly, that same image was labeled as male by these systems. And so we can see how systems can amplify what is already stressful and traumatic for trans people. So to return to the question earlier, what is gender for these systems? As I mentioned, gender can be understood through a multitude of perspectives. So it could be understood as a subjectively self-held identity, a self-presentation that you're making to others, a social construct that is defined and maintained through performative acts, and a demographic that's imposed on us by society or governments. But in the case of facial analysis and image labeling systems, we saw them collapse these perspectives into a singular worldview, and that is that presentation is what equals gender. And these services are actually designed to serve as an infrastructure for other people to use. So they have the potential to cascade into endless domains and can be embedded into numerous other infrastructures representing numerous other use cases. So here is an example of that. So this is a kind of a screenshot of the dating app Woo. Woo uses Amazon's gender classification to ensure that the user's selected gender matches the images that they're uploading. So in order to sign up for the service, you select your gender and then you upload an image, and it returns basically whether it is compatible or incompatible with that gender. In this case, I used, once again, kind of an image of myself, and it was incompatible. I also used an image of a singer that is incompatible. But when I Googled manly man and found this person with a beard and a beanie, it was compatible. And so in the hands of kind of third-party clients that are using these APIs, gender classification becomes further calcified into society. So someone like me couldn't access a service like Woo unless I change my appearance or conform to some ideal of what male looks like. And here we can see now familiar critiques of big data. So in the context of these cloud-based services, there's actually a shift from data that is being analyzed in aggregate to data that is being used as affordances by third parties. So a person's face and their associated gender are now being used as a feature of these systems. So thinking about what using gender as affordances in systems can be at its worst, it could be used to bar trans people from specific social spaces like bathrooms. And so this is a conversation that has been going on in the United States for quite some time and has made its way to the Supreme Court multiple times. And so that could be a real concern for people. It could also be used to restrict movement. There are already kind of issues around TSA for people who don't conform to expected gender binaries. And so TSA could also use gender in tandem with new facial recognition systems to kind of suss out who is who and who should be allowed to move across borders. And it could also be used to enact intentional violence by anti-trans governments, which sounds, rather dystopian, but these systems are being used to track ethnic minorities in China, for example. And so governments using these systems to track people who don't necessarily fit into what they believe should be viewed as a citizen or a person is not unheard of. It is something that is currently happening. And so this worldview is really harmful to everyone, whether that person is cisgender or trans, binary or non-binary, because it really enforces a rigid notion of what a normal man and a normal woman looks like and who even gets to be recognized at all. So artifacts have politics. If you're in information science or HCI, this is definitely something that we really believe in and hold on to. Thank you, Winner. Bowker and Starr remind us that political and social agendas are often first presented as purely technical interventions. As layers of a classification system become enfolded into a working infrastructure, the original political intervention becomes more and more firmly entrenched. It becomes taken for granted. And the current state of gender classification in computer vision is a political decision, and it's one that has become deeply embedded in its development. These politics exist in every layer of computer vision infrastructure, so it's not just in the training data, but the model itself and how that model can be used. So what can we do? So in this paper, we include numerous considerations for system design, data set design, and policy, but I'm just going to present a couple. So one is moving away from classification at all, so moving away from male-female classification and embracing more fluid markers of identity. So object labeling was actually a really interesting potential in this case, despite it being in its current state, kind of reinforcing binaries. But many current use cases being in marketing, something like object labeling is actually more contextually useful for that. So for example, you can improve the labeling of things like makeup or long hair or clothing style so that you are advertising products to people that would actually use them based on their appearance rather than their gender. And then another, I think policy is a really interesting place to think about interventions. So right now, facial analysis is subject to very little regulation, but we could look towards policy to intervene. So policies for how face images are collected and used might be the most effective way of mitigating harm to trans people and also people of marginalized races, ethnicities, sexualities, and other identities. So right now, The Fair Housing Act already extends anti-discrimination policies to online advertisers. So we can think about how policymakers might be able to expand legally protected classes to encompass facial analysis technologies. So it is critical that designers, researchers, and policymakers address gender in facial analysis and really all technical infrastructures. By doing this, we can ensure that computer vision services aren't being used in discriminatory or exclusionary ways, intentionally or not. But where do notions of gender and other identities even come from in these systems? So this leads me to my second study on how we've taught algorithms to see identity. And this is looking both at gender and race and how that is constructed in image databases for these systems. So we all experience the visible external features that are associated with race and gender when we're interacting with the world. And as a result of these interactions, we also hold our own affinities with race, gender, and a multitude of other identities. Race and gender have always been incorporated into technical systems. From the US Census to Facebook, we see technical representations of these identities everywhere. They've also become increasingly embedded as features used to train machine learning-based algorithms. So perhaps the most salient example of this is in facial analysis technology, since it's using your face. Within the last decade, this technology has quickly transitioned from theoretical research problem to commercial reality. So as I've been talking about, there are a number of companies, large and small, that are offering these services to clients to use in their products. Facial recognition is already widely used and is probably the most well-known example of a facial analysis technology. So for example, it's embedded into social media like Facebook, and it's also employed by law enforcement. Facial classification is less common in general, but it's most often used in targeted marketing campaigns currently and tracking consumer behavior inside of stores. So this is still something that you may have come into contact with while you were shopping or browsing. So historically, formally classifying race and gender has also resulted in harm, particularly for minorities. For example, differential access to healthcare for marginalized gender and the targeted extermination of racial groups. The outputs produced by facial analysis system are premised on their training data and evaluation data. And these are the images used to teach the system what a subject looks like and for the researchers to then evaluate whether that is what they expected. In this study, I analyzed race and gender in training databases from a critical discursive perspective. So I analyzed how race and gender are codified into 92 image databases, many of which are publicly accessible and widely used in computer vision research. To do this, I analyzed how race and gender are represented in image databases and how those representations are derived. So what categories are being employed to represent race and gender, what sources are being used to derive race and gender labels, and how are database authors describing the annotation procedures for race and gender categories. So to do this, I developed a codebook aimed at capturing answers to those research questions. I'm not going to go through all of this, but basically looking at whether the attributes are present, whether they're implicitly described. That's kind of, what are the statistics in the database versus explicitly where every image is annotated with a race or gender label. Sources in this case is how did the authors actually derive these definitions and whether those are present or absent. And then the annotation process is whether the authors described the annotation process at all. And so I saw vast inconsistencies across racial categories and methods for determining the race of a person in image data. Some databases employed free racial categories. For example, Microsoft Celeb 1 million and others employed 7, like 10K US adult faces. And we can also see from looking at these that some of the labels used might have social implications for those who are interacting with it. So Microsoft Celeb 1 million used labels like Caucasian, Mongoloid, and Negroid, which are, often viewed as pretty problematic terms to be using for people's race now. Meanwhile, as previously documented, in my own prior work and other prior work that I reviewed, once again, I found consistently binary categories for gender, but these often showed up in different ways. So the AR database, for example, just used M and F, and you can kind of, based on culture, you realize that this means male and female. And then PubFig actually had an annotation for male, but the only annotation for women was the label attractive woman. And then at the same time, I found that the majority of image databases rarely contain any underlying source material for how these identities are being defined. So further, when images are annotated with race and gender information, database authors rarely even describe the process of annotation. So who is doing the annotating and what visual cues are even leading them to make specific judgments about race and gender? The lack of transparency around race and gender makes it difficult, if not impossible, for outsiders to understand how identity-based decisions are being made when constructing databases. And such constructions are important. Categories of race and gender have been socio-historically linked to politics of oppression. Race classifications in the United States, for example, have determined every aspect of a person's life. Gender classifications have determined things like who can get access to certain spaces and healthcare. Such examples of older technologies of classification are now portable to new facial analysis technologies. In fact, it's already happening in research and practice. So like I was saying earlier, the New York Times has discussed pretty extensively how China is using facial analysis technology to identify Muslim minority Uyghurs. And the government is actually requesting companies to develop specifically ethnic classifications. And then in the first screenshot, we can see this is a paper that was published in the International Conference on Advanced Computer Control in 2010. This is in the IEEE proceedings, and it lays out morphology for 3 different ethnic groups in China. And so, within a decade, we could see how research on IEEE at this conference went from this kind of theoretical abstract problem to a reality that is now really altering the lives and endangering the lives of real people. And so more accurate and diverse data isn't going to fix issues with classifications that are inherently problematic and exclusionary and dangerous. So I posit the lack of similar engagement with ground truth, race, and gender data. It undermines the very purposes of image data databases to be usable, reliable, and accurate, which is something that's really important in the computer vision community. Further, it ignores the socio-historical reality of race and gender being messy, complex, and really cultural. So we thus observe race and gender categories that are socially historically complex, portrayed as obvious, static, and apolitical. And so in this paper, I also discuss opportunities for improving the current state of image database construction and documentation. So I'll just go over a couple of those as well. So for example, by actively acknowledging the socio-historical context that databases stem from, we can attempt to avoid replicating the harms done by historical classification systems. So in these publications documenting computer vision databases, there's very little engagement with the social reality of these categories. They're just kind of put out there as obvious and they're not discussed in terms of how they would actually impact people. By explicitly stating the limitations of use, we can help protect marginalized groups which might otherwise be harmed by the deployment of facial analysis technologies. So defining the limitations of use for databases is also uncommon. It's often mostly licenses meant to ensure that they aren't commercially used, but there isn't much out there about limiting how, how gender classification, for example, can be deployed. And by regularly revisiting or revising databases and retracting those deemed harmful, we can prevent their further entrenchment into future systems. And so this is also an interesting idea that is being talked a little bit more about as some authors are beginning to retract their databases. And so this is something that I would love to discuss with others because there's a tension here because now we can't really track, where that data is still currently being used. So addressing representational biases actually extends beyond diversifying data, which has been the focus of a lot of fairness research in this space. And it extends to representations themselves. So what is being represented and how? In terms of what we intend to classify, are we intending to classify gender and why? How we intend to classify? Are we only going to be classifying binary gender and why are we doing that? And how we define those classifications. So the language that's being used. When we say and label an image with something like attractive woman, what does that mean? And so these are questions that I think are inspired by this work and still kind of could use future depth on. So thank you so much for listening to this talk. And I created this kind of cute cat analysis system instead, which is obviously a much better use case of computer vision. And yeah, I'm happy to take any questions or have any conversations with anyone now.
Thank you so much, Morgan, for such a great presentation. It was fabulous. People have already excitedly asked a bunch of questions in the Q&A box. I just want to remind everyone else who's attending, please feel free to ask questions in the Q&A box and we will get to as many of them as we can. So the first question comes from Hunter, who asked what you thought about CHI, or the Computer Human Interaction Conference this year. And I think maybe to expand that question too, I'm wondering how you found that your work has been received within the kind of computer human interaction community and kind of like the levels of pushback or receptiveness that you've had.
Yeah, so I think for communities like CHI or CSCW specifically, so these social computing communities or these HCI communities, I've had a really great experience. I mean, I've been shocked in some ways by the really positive feedback I've had from, I guess, ACs and papers committees. I've won quite a few awards on this work, which is amazing because coming into this, I was like, of course, people aren't going to care about, I don't know, I just had this expectation, like trans people are kind of, always the outliers. So I just figured that it wouldn't be received as well as it is, but it has been received super well in these communities. I think the places I've gotten more pushback are actually from people who are primarily machine learning based researchers or trained in machine learning and also don't necessarily believe that, I guess it's more of the outlier thing. So I've definitely gotten comments that like, this is such a minority of people, like, why should we care? And those kinds of things. And so I think outside of the HSI community is a little more difficult. And now it's something that I actually actively prepare myself for when I'm giving a talk to that kind of audience. But yeah, I would say overall it's great. Even within those communities also, I think it's, I've had people reach out to me who are primarily machine learning trained researchers who are super interested in this too. But there's just sometimes there's a handful of people who don't seem to also like this kind of weird approach that I have that's like qualitative plus maybe some confusion matrices and things that they would traditionally use in their field.
Thank you. Mira, do you want to ask the next one?
Yeah, thank you so much for your presentation, Morgan. Lorena is asking, well, first Lorena says, this is incredible work, and then goes on to say, overly technical analyses pose a barrier to systemically excluded folks. The information might be unintelligible or seem irrelevant. Do you have any tips on how to share this systemically excluded youth in particular, as they might be grappling with their own gender identity and online mediated presence?
Yeah, I guess I feel like I try really hard to like lay out really high level views of some things that would otherwise be inaccessible to people. And I'm coming from a space that's, I'm not a trained computer scientist. So this is all also, I would say that has been such a barrier to like learning some of these things, is how it's portrayed, is like, it's almost, in some ways, it almost feels like purposefully difficult so that it's harder for people to understand. So I think it'd be great to know if this was accessible to people. So I don't know if like I have the best advice on how to make it more accessible beyond like, I think some simplified charts and simplified explanations help, or grounding things in examples really helps. Did I answer that full question? or is there another part of the question that I should focus on?
I think you answered it. And I also, for people who are attending and haven't read, Morgan has also written, as Morgan and I were discussing before the talk, some really accessible posts on Medium about this work as well, that I think people might find really helpful in beginning these conversations if people aren't interested in reading necessarily the academic texts. But yeah, I think that was a great answer. Gala asks, how did you get many images with multiple hashtags? So I think this was referring to kind of the first part of your talk when you were saying that it was about user hashtags. Did you get many images with multiple hashtags? If so, how did you manage?
Yeah, that was kind of another simplification that had to be done. So a lot of images, particularly images that people tag with non-binary genders or trans identities, had multiple hashtags. And so the way we handled it was really overly simplifying it, which was the hashtag that we scraped this for is a hashtag that we're using as the ground truth. But obviously this, erases other identities that are relevant to the people in the images and is a huge trade-off in that regard. So I mean, I would be interested to know how balancing that, like maybe testing all of them might change, but similarly, a lot of them, would be tagged with like multiple non-binary genders. And so the outcome would be the same in that case. Or, if it's tagged with trans woman and then like a non-binary gender, like demi girl or something, it would also be, the outcome would also be very similar. So although it's obviously simplifying, and I also, have, there's an ethical tension for me for even simplifying that. The fact that someone tags something trans woman, they want to be classified as female, that's a simplification as well. I do think that overall, for the purposes of this study, it's not misrepresenting too much, hopefully, especially in aggregate. But yeah, it was a decision that had to be made, and also balancing multiple identities was something we thought about how to do. So this data set wasn't super balanced. We didn't balance it in terms of age or perceived like ethnicity or race or tagged ethnicity or race or anything like that. And so that's also kind of a limitation. And this just compounds and this shows like how difficult it is to even build diverse data as so many identities compound, and then it's like, how do you even assess what those identities are? Sorry, that was a little bit of a rant, but yeah, we definitely acknowledge that that was true and had to simplify to deal with it, is like the short answer.
Awesome. An anonymous attendee asks, do you see space for this kind of work to progress in tandem with decolonization work? Because it seems to me that we are facing yet another example of the pervasiveness of colonization and imposed colonial views. For example, the gender binary and restrictive gender roles.
Yeah, this is something that this is like kind of similar to a piece that I've been working on recently, actually. I think that, yeah, I mean, I think it should be in tandem with decolonization work, because I think there's very little acknowledgement that the gender binary has been enacted through colonization, and now it's almost viewed as this natural thing that is like inherently true, right? Even in, feminist spaces, like this is something that I feel like isn't talked about a whole lot and probably should be. So when we're even, trying to do feminist work and acknowledge, experiences of trans people, often we don't talk about these categories are kind of a result of colonization. And so I personally would love to do more work in that regard. It's something that I've been thinking through a lot since I'm basically doing this historical kind of paper based on that notion. But yeah, it's not something I've seen when it comes to computer vision.
Thank you. Catherine writes, we're seeing companies using AI for human resources and staffing purposes, where they use facial recognition technology to determine if someone is, for instance, a good salesperson or if they're trustworthy. Given the issues surrounding gender and race you've outlined, how can this software ever be seen as ethical?
I don't think that it can. I mean, that might be, I think that all of these, the views on these are going to differ so much, right? Like my view is that it probably can't, because I now have this deep perspective that telling, I mean, to me, it's very like physiognomic, like it's, what is the underlying trait that we can see from your face or your facial expressions. And also, it's super ableist and things like that. So I don't think that it can be ethical. I think that if I were to think of the argument that it is ethical, I would imagine people would say, oh, we do this as humans all the time. Like just, interpersonally, we assess each other's character all the time. But I do think that is different, because there's a level of interaction happening. There's a level of, I can correct things, I can leave this conversation. Even with jobs, there's a power differential there interpersonally, but in aggregate, using other historical data of what looks like the best candidate, I think is much different than having one interviewer determine that. So I personally don't necessarily think that it is or could be ethical. Similarly, I think particularly those kinds of use cases, I've had similar questions about gender classification, like can it be ethical or used in a positive way? And so there are some tensions here, I think, between people who are trying to use this to assess equity in certain cases, like equity in media, which is like a very positive thing to do. Like gender is still a real thing. And so gender discrimination and things like media is still a very real thing. And it's very important, I think, for us to have assessments of what that looks like. And so I think ethics becomes a little more tense there around those kinds of trade-offs. Yeah.
Next, we have Vasiki. I apologize if I mispronounced that. She says, thank you for the wonderful talk. I was wondering if you have thoughts about the relationship between self-identification across multiple features in social media users and the targeted advertisements they receive. For example, I often wonder what Instagram is learning about me to recommend green alternatives to household products and gender neutral clothing, and what that means about how I'm presenting myself on the internet.
Yeah, I think this is a really interesting, almost more heavily black box kind of scenario. So I don't know. I mean, each service will probably use different variables to determine things like assign gender for marketing. They may sometimes, I mean, I would assume that some of them also use explicit, like your Facebook profile, you can assign male or female or some drop down box, right? So I think I'm not 100% sure. This is all, prediction or whatever, like assumptions. But it's possible that maybe they use a male female and they don't use anything else. I think that's very common. I know there was a piece recently saying that Google allows its advertisers to purposely not advertise to people who don't select gender, which is a whole like, okay, are we discriminating, job ads and things like that against non-binary people now? But I also know that there are proxies that will still be assigned to people on certain platforms. So I think on Facebook, you can look at those on like what it thinks you are. So I think it really depends on the advertiser. And it's really hard to know like what is the behavior that is leading to a certain assignment. So for me, it's actually very difficult to tell. Like I think sometimes on Facebook, I get advertisements that are relevant to the things that I've selected on my profile. And then I also get advertisements that might be relevant to my activity, which don't align with that. So I think it's also because there's a suite of, different algorithms of different companies that are gathering information. It's so hard for me to like guess what is leading to what and like how that's done, which is really frustrating. It's also very interesting. So I hadn't thought about this until I read Cheney Lippold's book about search algorithms and this like modulating algorithmic identity. And there's something also interesting to me about in these cases with computer vision, it's kind of, although you get a score, a probability score, it's often portrayed kind of like as a one and done. Whereas with tracking online, behavior tracking, it's actually like a modulating gender identity. So your gender identity can flip to the algorithm at any time based on your activity, which is interesting. It's still, I think, problematic because it's constantly being assigned to you without consent and all the other privacy issues, but it is like a different type of classification.
Thank you. So we have a question from a group. So they write, we're a group of HCI scholars and policymakers and trans people watching this presentation today together. This question has been asked by one of us. Have the problems highlighted in each framework been fed back to authors? How did they respond? And then they say, regarding pushback from machine learning researchers. And the next part of the question is, what is the best way to get them on board with this conversation?
So the framework, I'm not 100% sure what framework. I'm having a little hard time with the first part of the question. But in terms of how to get them to respond positively, I don't know. I feel like it's hard. If someone is particularly obstinate about it, I don't know that there's much to be done. I will say, sometimes and this is to be perfectly honest, like I sometimes alter how I talk about things based on my audience. That might not be something that everyone is comfortable doing or, wants to do. So you can, it's like, at what point do you trade off like your actual belief with something that might appeal to changing something? And so you could appeal to companies, you know, marketing, like how would this impact their potential clients or their potential income, which is what's important to those companies. And I think this is also why it remains so pervasive. I can say that after the How Computers See Gender paper, I had a couple of companies representatives reach out to me, and one of them was basically all they wanted to do was explain why they continue to do this. It wasn't like they wanted to have a conversation about what better to do, but it was a very defensive conversation. And so there is this like, I think there's almost there, it's like they're realizing that there might be a problem, but their clients are so important to them that that problem isn't important enough to address at this time. And so you can try to appeal to that. You can try to appeal to other forms of what is important to the machine learning community versus, the HCI community. Or you could, I mean, I think it won't necessarily work. I'm sorry, I'm like ranting again. I like to think through things as I talk, obviously. So I mean, other than that, like, I think I don't know if that's been successful for me, I will say. I think maybe it's made the conversation less hostile in some certain situations, but I don't know if it's been successful in getting them on board. And so this is definitely something that like, I would love to talk about and get advice on.
An anonymous attendee asks, what were the ethical or privacy considerations when you conducted the social media image scrapping?
Yeah, so this was, I mean, it's to me, it's rather problematic to scrape public data. It's a violation of expectations. This is something that Casey Fiesler has written about. When you're uploading images publicly on the internet, you don't necessarily think they're going to be used by researchers. So there's always this issue, whether it's Twitter data or other public data. So basically, we tried to figure out other methods for doing this that didn't involve that. And I would love to hear what they are if people have ideas, because in terms of gathering data for anything relevant to machine learning, whether it's auditing or not, it becomes really hard to do that at scale quickly. And I don't know. Yeah, I feel like for university teams too, it's going to be really hard. Like if you need like 2,000 images and you want to pay every person, that's going to be hard. I think that's like a great idea, like pay and get consent from every person. But I think it's going to be extremely difficult to do. And the trade-off there is that you will never be able to do a study that exposes companies or other research, basically the ethics of machine learning, if you don't have the data. And so that's kind of why we were like, okay, like the trade-off here is doing something that, is rather unethical, and, is a really hot topic right now in research. But then you can't even do the study without that data. And so this is also something that, one of my committee members asked me, which is like, what is more important to you, or what would you rather focus on, which is like the potential outcomes of biased or problematic classification or privacy. And I just think that the outcomes are really real. They're being used all the time. People are getting denied services by these systems. So focusing on the outcomes was really important to us. And then we did a lot of mitigation kind of to ensure that even though we had to scrape the data to make a data set, it was basically we deleted all the data after doing the study, and the study was published. I know it's very common in machine learning, and there's this open data kind of movement, and there's valid reasons for that. So you can test the data that's being used to train systems, right? But we felt it was not appropriate to share people's data, particularly because they're all, many of them are from marginalized groups. We also did ethical fabrication on the quotes, and we didn't use any images in any of our publications or anything like that. So ethical fabrication is basically, aggregating or rephrasing things by a participant so that it's not identifiable. Because this information is on the web, we didn't want people to be able to search a quote and find that person. So that is another kind of thing that we did. So yeah, basically it's a trade-off for sure. But it's good to, I think, if you're going to do something like this, to try to follow as many steps as possible to then protect the people whose data you are using.
Thank you. Thank you for going through your entire process on that. I think it's really helpful for people listening who are researchers, and for people who want to understand the methods and methodologies behind the research. So this is actually my own question, which is, I was hoping you could speak a little bit more about how object labeling itself is gendered. You kind of mentioned that quickly, but I was hoping you could kind of expand on that.
Yeah, so generally it was gendered, I think, I guess you could say in two ways. So one is that the object labels just kind of replicate in some ways the gender classification. So you get object labels like man or boy or things like that. And then the other way is that they were kind of like implicit modifiers, like the gender was kind of used as a modifier for a noun or whatever. So like I said, this was I don't think that any of them were male based or masculine. It was very much like femininity or womanness was treated as kind of like an altering thing. So like, how do we make this label more specific? Okay, it's a starlet instead of a star, or it's a woman's portrait photo instead of just a portrait photo. So that's generally how we saw it. But it was different for each service, which is also interesting. It begs the question, like, how is this being annotated, or where are these labels coming from? Because I think it was IBM's was particularly detailed and more gendered because it was very detailed, whereas Google was so high level that it was mostly just like man and woman. And what's also interesting is since then they've removed those labels as well, and they also, even during the study, they removed classification. So that's another kind of interesting thing about even assessing these kinds of systems. But yeah, I hope that answers your question.
Yeah, thank you so much for clarifying that. Also, I had actually misrepresented Lorena's question. So it was the earlier question that had to do with any tips on sharing this with systematically excluded youth in particular. And I was like, my follow-up question on it had been about kind of like the medium piece and such, but Lorena says that the focus was on youth specifically.
Okay, so how could this be accessible to youth who might be impacted? That's a really good question. Honestly, I can say that it's maybe not something I thought about. Yeah, that is a great question, because I wouldn't call myself, I wouldn't want to claim that I am like a great youth mentor or like good at teaching these kinds of things to youth. So I don't know what would be a good way to do it. I can assume that certain people might be more visual, so maybe there are visual ways to do this. I know that, for example, I think it was Pew has this very interesting kind of easy to read piece on how gender classification is not done by systems the same way it's done by humans. So for example, a pixel, they have like a little GIF. Yes, I say GIF. They have a GIF that basically shows if you put a pixel here, it might flip the gender classification, which is not something that humans would think about. And so for me, at least, I've found that these kinds of infographics and videos that people have explaining computer vision are super useful because they kind of put it in terms of human. I think that's the key, is like, how do we make it human interpretable in some way? Because the system itself might not be human interpretable. So explaining it as like, you know, if you were looking at someone, would you stare at this like one spot on their head to make that classification? Probably not. So I don't know how useful this still is to answer that question, but yeah, I think I know that there are some more resources out there by, you know, Pew and like researchers who are trying to explain this in a really accessible way. And sometimes I try to go to those because the most I've done is, you know, undergrad lectures. But usually it seems to connect with them to have these kind of visual examples as well as like simple explanations.
Thank you so much. And that was all of the questions from our audience members. Morgan, I want to thank you so much for your wonderful presentation. And I want to thank everyone who's come and attended. Thank you to Fenella for doing the captions. And thank you, Mira, for doing some of the technical side of things. Thank you everyone so much. We hope we see you next week for Stephanie Dinkins's talk. And we will have the video up within the week on our website, as well as there's other videos there for you to check out of past events. So thank you so much, everyone. Have a great afternoon, or morning, I guess, in the case of some of you.
Thank you.